This is Steve with Wallaroo AI, and today we're going to be taking a look at how we can use the Wallaroo platform to deploy AI models to the edge, specifically targeting Jetson hardware leveraging both the ARM processor as well as the embedded NVIDIA GPU present on the Jetson. The model we're going to be deploying here today is a series of two models for computer vision, specifically trained to detect ships in images. This was designed to be deployed onto a satellite in orbit and to be able to identify ships at the edge as the images are captured on orbit. Once I have these models trained, let's take a look at how we can use the Wallaroo platform to actually deploy them. From my model development environment here, in this case we can see a Python Jupyter notebook, I'm going to import my Wallaroo SDK. This is then going to allow me to create a client connection to my installed Wallaroo instance, which could be in your favorite cloud or in your on-prem environment. I can then set a workspace to organize my work. Now that I have my connection to my Wallaroo instance, I can go ahead and actually upload and package my models for deployment. I do this by calling the upload model function, which both does that physical transmission of my model artifact to Wallaroo, as well as automatically packages it based on the framework. And so I upload my YOLO model as well as my SSD Lite model. Both of these are Onyx models, and so I tell Wallaroo that as well. And with Wallaroo, I can upload models from a number of frameworks, including popular options like PyTorch, TensorFlow, XGBoost, sklearn, as well as even arbitrary Python code that I'd like to treat as a model. Next, I can define a deployment configuration to tell Wallaroo what hardware to use for my model deployment. If I'm targeting a cloud deployment, then this can be the hardware that will power my deployment long term. If my target is ultimately the edge, then this is a good place to test out a hardware profile similar to what I expect in my edge environment. Once I have my model and my deployment configuration defined, I can combine them into a pipeline. I go ahead and define my pipeline, add my model to it, and then deploy it with my deployment configuration. This will actually provision the hardware from my cloud or on-prem instance where Wallaroo is installed and spin up a deployed endpoint for my pipeline. Now that that deployment is finished, I can examine the endpoint for one of my pipelines, and this is now a fully functional inference microservice ready to receive requests and data and perform inference. And I was able to get this fully deployed in my cloud-based environment without needing to get into the weeds of any tools like Docker or Kubernetes. So if cloud is my ultimate target, I'm done at this point. I am fully deployed and in production. But now let's see how we can actually extend this out to an edge deployment. The first thing that I do here is define or revise my deployment configuration for my edge device. And you can see here we have a similar hardware profile as before, but because we're targeting a Jetson, you can see that I want to target an ARM architecture and make sure that I'm leveraging the Jetson embedded GPU acceleration. Once I have these things defined, I can call the publish command on my pipeline. This will take everything that we've built so far and make it completely self-contained for an edge deployment by packaging up my pipeline artifact itself, as well as the Wallaroo engine built for my chosen architecture and acceleration as a Docker container that I can deploy on the edge. And I can see those artifacts as well as a nicely formatted Docker run command as the outputs of my publish here that I can simply copy and paste over to my edge device. Once I have these two pipelines deployed on my Jetson, they're available for local inference, and you can see that I can build those inference calls to my models directly into the broader application code here. Once I have these pipelines in production, whether that be in the cloud or at the edge, the Wallaroo Operations Center also gives me an easy-to-use dashboard that I can use to manage and observe these models. Clicking into one of these pipelines, you can see I can easily see a wealth of information, including how I can access the cloud-deployed version, the version history of it, the metrics associated with it, and even the logs coming back from any cloud or edge deployments that I have. These centralized logs from my edge deployments also allow me to power Wallaroo's assays, which are an automated drift detection framework that can monitor my inputs or outputs of my pipeline for drift. And I can see here, for instance, setting up an assay on the average pixel intensity of my inputs to this pipeline so that I can see over time if my input space is changing, which may be an early warning sign of degradation of my model's results. Wallaroo allows me to easily be alerted in the event that drift is occurring and also dig into this data both at the macro and micro level to determine if there's a change in my underlying data that I need to address through updating my model or another intervention. And because I can configure assays to monitor drift on specific edge locations or globally, I also have the ability to be as granular as I want in this analysis. Today we've seen how the Wallaroo platform allows me to easily package and deploy my models to the cloud as well as to edge hardware such as my Jetson board, as well as take advantage of different architectures and accelerators that may be available in the cloud or at the edge. Beyond that, it allows me to monitor these models in production and be easily alerted if any drift is occurring so that I can take appropriate action to ensure that my models are always providing the highest quality predictions in production.